All right, so in this lesson, we're going to look at distribution and factoring. So just to review here in the beginning, the distributive property is when we multiply a term to each term inside of a grouping symbol. So generally parentheses or brackets there. The other important thing is before you distribute to make sure that whatever you're distributing to is distributing over some addition or subtraction. So if we take a look at some examples here that we can distribute for, notice all of these have a plus or minus sign in between the terms inside of the parentheses. This is very different from, say, if we had -4 times 2x y. This would not be something we would distribute to. This is just all multiplication. So the difference is the plus or minus right there in the middle. So to distribute, it's important that you stay organized with your work, and one way I like to do that is to use arrows. So we'll start with this first one over here. We're going to distribute the 6 to everything inside. That means 6 is being multiplied by the entire m plus 6. So one way to show that is to use some arrows, and we'll multiply the 6 times the m, which gives us 6m. And the 6 also needs to multiply by that 6 over there, which becomes positive 36. There's a plus in the middle, so I just bring that down. So 6 times m plus 6 is 6m plus 36. So this is your distributed expression. So here's our next one, -4 times 2x minus 3y. This one has some negatives in it, so let's look at what happens here. We'll multiply -4 times 2x, which is -8x. Then we're doing -4 times, this time we have a -3y, because remember, subtraction is the same thing as plus a negative. So if you wanted, you could change this to plus a negative, or you can just notice that it's a negative times a negative, meaning it will become a positive. So -4 times -3y is positive 12y. So when this one multiplies out, it gives us the -8x plus 12y. In this next example problem, we're distributing y to the y minus 8, all in parentheses. This one has some multiplying of variables, so we have to jog back our memories to some monomial rules. So a y times a y, we add the exponent, so it's y squared. And y times a -8 is minus 8y. All right, and our last one has some multiplying with fractions in it. So when you have fractions that you're multiplying by whole numbers, remember that this number outside, we could write this over 1, and you basically can use some cross-canceling rules to help you with this multiplication. So 8 cleanly divides out of 48 and 8, so I could imagine cross-canceling those, and I'd be left with a 6 here if I canceled. This would become a 1. So this is really 48 times 3/8 x is really 6 times 3, 18x. Now we do the 48 times, and I'll erase this 6, that whole 48 now gets multiplied by 7/12. So again, we cross cancel, and 48 and 12 share that common factor of 12. So here I'd be left with a 4, so 4 times 7 is 28. So when we finish distributing that one, it's 18x plus 28. All right, so that's some practice with distributing. Distribution often goes over multiplication. However, we can also see it go and distribute over some division. So remember that division can be rewritten as multiplying by a reciprocal. So the division will just be distributed to each term that is added or subtracted. So let's look at some examples here. So 4m plus 6 divided all by -2 is really can be rewritten as 4m plus 6 if we copy, change, flip to 4m plus 6 times and flip the -2, remember this is over 1, to a -1/2. So when you do that, you can then see, okay, this is still a distribution problem where I'm distributing now negative 1/2 to each term inside of that parentheses. So it's just on the back end here, but we still multiply the negative 1/2 to everything inside. So that will leave us with negative 2n minus 3. Okay? And so that's what we get when we distribute. Now, the other way to do that, which is kind of a shorter cut way, is if you look at this 4n plus 6 all divided by negative 2, a different way to write that is to write all over the negative 2, all divided by negative 2. And if you do that, that means we're going to divide 4m by negative 2 and the 6 by negative 2. So everything gets divided by negative 2, still giving us negative 2m minus 3. So you can see however you want to think about it, we'll still arrive at the same solution or simplified answer. So let's practice some distribution with division. So here we're dividing the entire 9 plus 15x by negative 3, meaning we're going to divide 9 by negative 3 and 15x by negative 3. So 9 divided by negative 3 is negative 3. 15x divided by negative 3 is negative 5x. So this distributes to negative 3 minus 5x. And you can see you can also write it as plus a negative. It's the same thing. We can also show distribution all over that common value we're distributing by. So here we're dividing everything by 5, meaning the 5n divides by 5, the 15m by 5, and the negative 40 by 5. Take a moment and do that. We should get n plus 3m minus 8 after we divide each part there. For this next one, we're going to divide negative 7x by 2, negative 4y by 2, and the 6 by 2. Now, negative 7/2 will become a decimal. For my class, you can often just leave whatever those improper fractions are as simplified improper fractions. So I would be fine with you leaving this as negative 7/2 x minus 2y plus 3. Because it's a nice clean decimal, you can go ahead and all the way divide it to be negative 3.5x minus 2y plus 3, but I would take either one of these. Okay, and this last one's a little bit different because there's an added step that needs to happen. Here we are dividing everything by 6, but you'll notice our numerator is not yet simplified. So there's some distribution that needs to happen up top first. So first we're going to distribute the 9 to 2n to get 18n, and then the 9 to the 10 to get plus 90, and divide that all by 6. Now we'll divide 18n by 6, 90 by 6, and that leaves us with, if this would go away, 3n plus 15. So that covers all of the distribution for this lesson. So we've now looked at distributing with multiplication and division. Next, we're going to look at factoring. So this is where we're going to take our distribution kind of to the next level. So remember, a common factor is a factor of each term in an expression. Factors multiply out to give us our products. So factoring out a common factor is like using our distributive property but going backwards. So we're going to be looking to find common factors in our expressions now. So if you're asked to factor an expression, that means look at your terms all in the expression and look for a common factor that they share. And if you find that common factor, we're going to divide it out of every term. So I'll show you what that looks like. So if we look at 4x and 8y. 4x and 8y share a common factor of 4. So what this means is I can cleanly divide 4x by 4 and 8y by 4. So one way to write that is show that I can cleanly divide each one by 4. Well, if I divide 4x by 4, that's going to leave me with 1x, and 8y divided by 4 leaves me with 2y. Another way to think of it, though, is that we're pulling this 4 out. If I just rewrite my expression as x plus 2y, I've changed it. Hopefully you can see x plus 2y is not 4x plus 8y. What we did is we divided a 4 out, so it's important in our answer that we keep the 4 written in our answer. So you'll notice that we'll put the 4 outside of the parentheses, so to show the 4 times the x plus 2y. You are not fully factored unless you have the 4, then the parentheses, and everything that's left inside. A nice thing about factoring is you can always check your work by multiplying it back out. So if I tried 4 times x, it gives me 4x. 4 times 2y is plus 8y. And so I can confirm that this is properly factored. So let's look to our next problem and find the GCF of these terms. So 3x and ax. They don't share any common factors as numbers, but they do both share an x. So in this case, your greatest common factor that we could pull out is going to be x, meaning I'm going to divide an x out of my first term and my second term, so I'm pulling that x out of everything. So I like to kind of use the arrows to remind myself that x is coming out. So I'll put the x outside of a parentheses. And now I write down what's left after I divide the x out. So 3x divided by x, and you can write it if you want, the x's cancel, we're left with a 3. Ax divided by x, x's cancel, we're left with an a. So there is the factored version of the 3x minus ax. There's a couple more for you to try, so I'll let you try factoring out the common factor, and again, look for the greatest common factor, numbers and variables, of these next two examples. Okay, so for this one, hopefully you noticed that a 3x could cleanly divide out of both parts. So that should leave us with 3x times 2x minus 3. And here we had a 4x that cleanly divides out of both parts. So we're left with 4x outside, and they're both canceled. So just a y. Here both cancel, just a z. And with this last one, the GCF is a 3. So I'll pull 3 out of each. So 9 divided by 3 is 3. 12 divided by 3 is 4. And don't forget your x. Make sure you notice that solutions are written like this here for factoring. You have to have the number, the open parentheses, and everything inside. Do not, on your homework, just give me 3 or 3x or 4. Make sure you write what's left in parentheses. And lastly, to very quickly review combining like terms, which I know is something you did all in pre-algebra. Like terms are two terms in an expression that have the same variables raised to the same powers. The coefficient of like terms can be added and subtracted, but when you combine your like terms, the variable and power cannot change. So let's take a quick look at that reviewing. I like to use underlining to indicate which ones are my like terms here. So notice this first term has an x to the first power, but our second term has a y to the first power. So those are not like terms. They have different variables. This last term has an x to the first power, though, which is like the first. So I'm giving those both a 1 underline, and I'm just leaving this one, the 4y, without anything because it does not share a term with anything else. So I can combine 3x minus 7x. You may want to circle the signs in front of the like terms to notice it's a minus, but that leaves us with negative 4x, and just bring down your plus 4y. In this next one, you'll notice all three terms have x's, but the difference is this one and this one have powers of 2 on the x's. This one's an x to the first. So these two are like terms. This one is not a like term with the rest of them. So I'm just going to bring down the 20x. And then negative 15x squared plus 2x squared. Notice I'm reading the signs in front. Negative 15 plus 2 is negative 13. And just bring down the x squared. That part doesn't change. 9xy is a like term with 15. Negative 15xy. The 13x will not combine with anything. So this leaves us with negative 6xy plus 13x. And in this last one, we get several things from today's lesson. We have to first distribute. Distribute first to simplify, giving us 10x minus 40. Bring down your plus 3, your plus 6x. Now I can combine any like terms I see. 40 and 3 can combine because they're both just numbers. So 10x plus 6x is 16x. Negative 40 plus 3 is negative 37. And that concludes our lesson today. So you can now move on to practicing.